All right, so today we are learning 4.2 greatest common factor. We started going over some examples on Friday, so we're just going to kind of backtrack on a few of those, make sure you understand it. We'll talk about example 3 today, and then we'll do some classwork. So everybody should be on page 164. Page 164, 4.2 greatest common factor. Everybody there? Page 164 in your books, guys. Dale, page 164. All right, first of all, greatest common factor, what is it? The GCF is the largest common factor. Common is the key word. Common factor of two or more numbers. So the largest number factor that two numbers have in common. In example 1, we can find the GCF by listing the factors. There's two ways to find the GCF. One is by listing factors. The other one is prime factorization. So if I asked you to find the GCF of 14, 35, and 63 by listing the factors of each number, okay, you would start off by basically listing them vertically. You obviously will always start off with the factor 1. All right, and I want you to go ahead and try to list out the rest of the factors. The factors of 14 are, class, 1, 2, 7, and 14. What about for 35? 1, 5, 7, and 35. What about 63? 1, 3, no. 21. Good, Tyler. Then 63. All right, and you can check it. 1 times 63, 3 times 21, and 7 times 9. All right, they'll all have a pair. Okay, so now that I've listed all the factors, what's the biggest one that they all have in common? Sorry, I don't know why I wrote 37. It should have been 35. It is 7. 7 is the biggest number that they all have in common, so I would say GCF is 7. All right, so that's how I would find GCF, by listing the factors. Now, if you had really big numbers, like let's say 105 and 225, okay, we don't want to list all the factors for these numbers. That would take us too long. So to find GCF by listing factors, we're usually dealing with smaller numbers. Once we get into the larger numbers, we want to use prime factorization. That's our other method for finding GCF. So go ahead and do the prime factorization of these two numbers. Okay, so let's do the upside down division way. 5 goes into 105 21 times. 3 goes into 21 7 times. 5 goes into 225 45 times. 5 goes into 45 9 times. 3 goes into 9 3 times. Now I have the prime factorization. Now some of you did factor trees. That's perfectly fine. Just make sure that you have the same set of prime numbers. Now what's the next thing we do to find GCF? Nope. You list them out. List them out. And no, you're not looking for the highest common number. That's only with listing factors. Okay, we list out our prime factors in order, least to greatest. 3 times 5 times 7. For 225, we do 3 times 3 times 5 times 5. Now what do we do? Anybody remember? Vanessa? Okay, very good. Circle the pairs. Both numbers have a 3 in common. Any other numbers in common? Dale? 5. Both have a 5 in common. So for each one, can somebody get the door, please? For each one, you're going to list it once in the GCF. So GCF equals 3 times 5, which is 15. And that's our final answer. Okay? So GCF is 15. How do we find that? We did prime factorization of both numbers, listed off the prime factors, identified the common numbers. The numbers in common, if there's more than one, multiply them together, and you have your answer. Now, in example 3, We're telling whether the numbers are relatively prime, okay? Whether or not they're relatively prime. Well, the first thing you need to know is, what does it mean for numbers to be relatively prime? Two or more numbers are relatively prime when the only common factor is 1. Okay, well, 1's a factor for every number. So what is it saying? It's saying it doesn't have any other numbers in common except for the number 1. So let's look at the numbers 28 and 45. Let's start off by doing the prime factorization of both numbers. All right, so two numbers multiplied together that give us 28. What? 4 and 7. 2 times 2 times 7. Okay, that's done. Now I have 9 times 5. Break down the 9. 3 times 3 times 5. Okay, now I have the prime factorization of both numbers. All right, so now that we have our prime factorization, remember, you could have done upside down division as long as you end up with the same numbers. So now we go ahead and list our factors. We're looking for the GCF here. We have 2 times 2 times 7, and we have 3 times 3 times 5. But there's nothing in common, right? There's nothing that we can circle. Because there are no 2's in 45, there's no 3's in 28. They don't share any common factors except what factor? 1. Okay, and that's the one that we know is understood because 1 is a factor in every number. Okay, so when the only common factor is 1, we would say GCF is 1 and the numbers are relatively prime. And that is our answer.